Thanks, Martin. Yeah, so my outing was done already. I'm an engineer, I'm not a data scientist, so this talk is also more about how to get data ready for further evaluation, for analysis, and maybe also more an engineering practical approach, which is referred to in this talk. Before getting more into details, let me start with one general consideration. That was, when I got the invitation industrial data science, my question was, what is the basic difference in between scientific data science or general data science and industrial data science? And of course, there are more people wearing ties in industry. But apart from this, I think there's one very important thing, and that in industry, more people care about money. And so I want to start with one general slide. It's from a study which was issued in 2015. In 2015 from Roland Berger. I would suggest you the reading because it's very interesting and it compares a lot what has happened in other parts of industry, consumer industry before, and telecommunications. And at the end, it says there's a very high amount of money to gain in what under the line is industrial gross value, that there is a possibility to gain the industrial gross value by 1,250 billion euro in the next 10 years. And if we all excel in doing what is called digital transformation, if we get the things inside our companies and if we get better in this. And the other side is that there is a possible loss of 605 billion euro. I think these are very impressive numbers. And what is also maybe the most important part of this study for me is that they identify 4 areas of action that are required to excel, to get better in this field and to be on the right side of the arrow on the green part. And they were partly mentioned before. I want to tell you them. It's at first increase digital knowledge inside your companies. So it's necessary to have people inside the company which at least know the chances and which can use the tools. And so it's not everything possible to buy from external companies, and it's necessary to get a certain insight inside the companies. So by hiring or by encouraging people to get inside digital tools, that's, I think, a very important point. The next is, they say use standardization, because the past has shown that standardized standards can very much help, especially cross-industry standards can help to benefit from results of other industries and to get access to cheaper solutions and to decrease the amount of money which is necessary to create a solution. And so look for the right standards, and I think RapidMiner is one of these. It's also a very important part. Then, third point sounds simple, but who has worked once in a company who has low access to internet services knows what is meant in a global, national way, or also in the single workstation. That's increased bandwidth. Try to get everyone with good internet access, encourage people to use the tools, but enable them also. And the fourth is use networking. So that's why we're here today. And I think it's a good opportunity to share experiences in between engineering and data science and other sciences on these platforms. And networking starts usually with introducing yourselves or ourselves. And so I want to introduce my company. I don't think that anybody of you knows Achenbach Buschhütten. We are a small company, 350 employees, but there are some remarkable things about this company. And at least 2 of them I want to mention. One is that we are world market leader in one specific branch. And the branch is the rolling of thin aluminum foil. So we build the rolling mills which are producing thin aluminum foil. And the majority of thin aluminum products in the world comes from our machines. And I think every one of you has maybe today, at least this week, touched products that are produced in a certain point of time on our machines, like household foils or closures, caps, cans, coffee caps, and so on. The second remarkable thing is that we are a very old company. We are maybe, or for sure, we are one of the oldest family-owned companies in Germany. We were founded in 1452. And by this way, we can say that we have successfully passed all the industrial revolutions that were mentioned before. And there are some things that we can learn also from this company history. And one major thing is that it's really essential to look at new technologies and try to insert the results of these new technologies into our product and improve the product by this way. And so somehow, as a small company, we became also experts in integration. And that's what we also did when we did our steps into digitalization. We tried to integrate as much as we can from what is already on the market. So basically, this is already the engineering approach to data analysis. What we need as engineers to analyze a problem is, of course, we need data. And at the end, looking at the basics, no learning algorithm in the world can work without having data. So it's essential to have a solution to collect data in a broad range, because if we look at one specific use case, of course, it's clear that we can reduce the amount of data which is necessary for a solution. But if we want to create a framework, something which can work in the future, where in the future there is access to the information of the past, which is necessary, like humans know, operators of machines know what was the situation 1 year ago, it's necessary to collect data on a broad range and to find a solution to save them on a broad range. And this is why we came to no compromises, without compromises, to a cloud-based solution. Because in the cloud we found lots of, an incredible amount of space to save data and computational possibilities to analyze data visually, which was actually our first step. And it was somehow clear that if we solve the first 3 points, then we would have much more possibilities to find easily machine learning solutions. And at the end, we can do what we want. We want to have smarter machines and smarter design of machines, but also to support our customers with their optimization. So that's the point. When we went out 3 years ago, actually, we did not find any solution that was really able to transmit data systematically on a broad range to the cloud. And at the end, we found a partner which gave us an opportunity to develop together this small computer box, which now is used, and I will say more details about that later. At first, if we are at the point that we need cloud computing desperately to handle big data, to handle the analysis of big data, there's, at least in my discussions, only one major point which is raised from the people. And this major point is security. So I want to place some arguments about security in cloud computing, just to discuss also this. Let's begin here. Machinery networks. If people know machinery networks, they know they are one of the insecurest places in IT technology, because there are NT computers still working also in modern machines. There are very old operating systems which are no more supported by security features. So the classic approach was to isolate the machinery network completely. But now people want to have access to this data, and they have to open somewhere access to this data. Using a memory stick is for sure the wrongest idea. Opening an inbound port in the firewall is still a risk, because remember, there's an unsecure network behind here. And so our solution was, we want the machine to decide or configure at the machine side what data to send. And we don't need inbound traffic, we just open outbound traffic, outbound ports, and by this we can have a safe transmission inside the cloud. Discussing about cloud data centers by Google or Amazon, I think there are thousands of arguments. I can mention some of them. In Google, I think above 700 engineers are just working for security. They analyze data streams to have anomaly detection. They have a reward program for people showing leaks in their systems, and they get certified by third parties against standards. So everyone who says, okay, cloud storage could be a potential risk in data storage, maybe should compare with his own IT department, how many people, what's their knowledge, what they're doing. So that's the next point. And the last is, of course, the user. Biggest risk, but there are technologies available at the market, technologies that we have integrated. In this case, specifically OneLogin, to have identity provision and to have safe access to different services. And by this way, I think we have created a solution which is safer or more secure than a solution which is only residing in a local network and having all the drawbacks from local solutions, like what's about cross-national comparison of machines and so on. So, coming back to standards, when we wanted to connect to a maximum of sensors and actuators in our machinery world, we found that it's enough to realize two interfaces, or actually three interfaces. One is to IBA systems. IBA systems is very popular, at least in rolling mills and big industries, because they have a connectivity to remote buses, to virtually every remote bus, and they have connectivity, very high configurable, to PLC systems, different PLC systems. But the IBA system is creating proprietary DAT files. So if we produce one coil, if we produce one unit, they store it in a file in the file system. But there's a second way, I would show it to you on the next slide, to generate aggregated data, pre-evaluated data, feature extraction inside a SQL database. And of course, if we want to have real-time streams, it's necessary to have access to the real-time data, and that's the new standard UPC Unified Architecture, which is implemented right now on every new system, and where there are hardware accessible on the market to also interfere with old PLC systems like S7400 or S7300, which we actually did so far. So let's talk about these three interfaces. We wanted to solve the access to these three interfaces because they are available in our machinery networks. Let's start with OPC UA. At the end, we just needed a client which registers for the data in the server, and to have the client, to give the client the ability to be configured by a small web interface on site. What's the cloud backend endpoint? What is the OPC server side? And then we can create this data stream. That's it. We have the data in the cloud. Cloud solution for us is Google BigQuery, because we found many advantages inside the BigQuery solution. For big data amounts, we have low access times and good performance and good interfaces. This is the look at the IBA interface. IBA provides a very good analytics software to be run on Windows computers in a local network. So you can have a look at different dimensions of your data. It's an engineering tool that we use since many, many years. But you can also use the tool to extract automatically features. There's a job coordinator, this one, that coordinator, which can trigger evaluations. And with each evaluation at product end or at time-based triggers, we can launch an analysis, and the analysis will write the data to the SQL database. And having the data in the SQL database, we have the same process as before, just necessary to get the right configuration of the machinery SQL side and the backend side, and we can transmit the data out to the cloud storage. Last point was DAT files. It sounds the most simple thing, but it was actually the most complicated because we didn't want to open an inbound port. So there's no way to connect directly inside the machinery network from the user outside in the world who wants to get access to a DAT file. By the way, DAT files have the advantage that they can go down to granularity, that they can go down in the resolution down to 1 milliseconds or less. And that's actually not possible to transmit in a stream in the cloud. So we wanted to have this access up on request. And the solution that we found is we have our dashboards. The dashboard can create a request. The request is written in a list together with the email of the recipient. And after sending this request to the list, when the plug delivers next time his data, because it does it regularly, he will take the request with it, find the file, and send the file back to the data backend. And then there's an email generated with a download link, and the user can get his IBA file on his local Windows machine and make the analysis of this special unit. So that was all for getting the data ready in the back end and for analysis. But when we were at that point, we've seen that there are much more things to do and much more things that are very helpful for further analysis. And that's a kind of stream management. If we get a stream of data inside our back end, of course we want to have an additional visualization of the data, because everywhere in the world it's helpful to have visualized real-time KPIs, but also every second an update about production quality and so on. There are many possible use cases here. But there's also something more, because with the incoming data, I may want to launch an information to my service manager that a specific temperature is increasing a certain value. So we have worked in a trigger interface which can be time-based or event-based. And the trigger interface will specify calculations, and they can create emailing, or they can create another data stream with higher level information back into our stream management. And at the end, we all get this in our big database. And the rest then is just analyzing the data and again integrating all that we can get from the market for optimum data analysis. And what we found in the first step was Tableau, because Tableau has very strong web interfaces. The graph on the right side before was created with Tableau. It's quite easy to use, and for visual analysis, maybe one of the market-leading tools. Of course, we needed security, user security, as I said on the previous slide. So that was why we integrated OneLogin. We have all the login logics that we can use from the OneLogin server. We have group management and roles management, by that without implementing it ourselves. Then we get into the system, we see at first a view of all assets, real-time values of machinery, speed, and online status, and so on. As I said, real-time views of the actual production status, but also real-time views possible from KPIs. And the last is we can visualize data, very flexible and very powerful, by creating dashboards with Tableau. So that's where we are. We have integrated these three standard tools, also for the machinery field, IBA and OPC UA. And now we are at the point that we want the next step. We need standards for machinery learning and artificial intelligence. And here we found one major solution which is quite easy to integrate because of the capabilities to generate web apps and deploy solutions on cloud servers. And that's why we are currently integrating RapidMiner server inside our solutions to have standards in access to BigQuery, to have standard outputs and insert them inside our dashboards. And the next thing, I admit, what we are also working at is MATLAB services, because we have lots of MATLAB solutions already running in our engineering field, and it's really helpful to find a possibility to run them also in the cloud for digital twins or whatever. Of course, once in the cloud, another advantage is that we have access to cloud database. We can incorporate other databases like production planning or everything which is only by organizatorical features to open for analysis, and so we can create lots of values from these data access. And so almost my time is over. Let me finish with some impressions what we can do with the things we have already implemented. It's something like standard dashboards or lean dashboards about specific KPIs. They are all interactive, and they all come from this kind of web-based editor. So it's possible for the user of our system to create visual analysis just using his browser under some conditions. And the next steps will be to have solutions like this, to get production sorted in trees, to have feature extraction. But that's next step for us, because we now think we did most of the things that were mentioned before to be that difficult and that time consuming to collect the data, to get it at the fingertips of the data scientists, and integrating all these solutions together. We should have the possibility to have good access to data, to have good possibilities for comparison, and to provide also the right computational power to our customers. So that's all. Thank you for your attention.
Very interesting talk. Thank you very much. You said you are using Google BigQuery for your cloud solution. When I think about cloud solutions, there are 3, maybe 4 competitors that come in mind for me already, like AWS, Azure, or IBM. But Google wasn't that far on this.
Yeah, that's one characteristic maybe of Google, that it's not really on the lists so much, but they always provide very powerful features and less powerful marketing, in my opinion. So they really give very powerful services for relatively low prices compared with others. For me, there are 3 big cloud solutions: Azure and AWS. And we were lucky to find a partner, the guys who had developed that box so far, who were already Google partner. But by them, we've seen a lot of advantages in the field of Google Cloud Computing. And still today, when we are comparing and trying to work with virtual machines in other cloud environments, because sometimes it's necessary, we see that there are a lot of advantages inside Google Cloud.
And does Google also provide the data security law restrictions that Germany has applied on any industry solution?
Okay, legal aspects are always something you must care for without regard of the provider, because the provider, like also Azure, will just say we work on the data on your order. And what of course is necessary if we talk about personal data, personal related data, and that's the only thing which is really protected nowadays. We can guarantee that the data is stored in Europe. So that's one major constraint which is usually given. But of course there are many legal questions to answer. We are about to work on that, but that's not part of this talk for sure.
Thank you.
Welcome.
One additional question? Okay.
What's the typical data flow that you can send from the plants?
We get one data set with all columns, any 0.1 second. But we do not stream them in this 0.1 second. We stream them every 10 seconds. We put the packages, and then inside the package there are 100 values. So we have a resolution. At the end, in the database, we have again a resolution of 0.1 seconds.
For how many sensors?
300, 400. There's not really a limitation even today. I was very ancient when we started the project. What would be the limitation given by bandwidth and networks? But it's not really there. Actually, the limitation is more given by PLC computational power. If the OPC service is running on the PLC, it takes a certain amount of computational power on the PLC, and if we increase the amount of data, of changing data too much, then the PLC will get too much occupied.
So the bandwidth is not an issue.
Of course, if the bandwidth is too low, there are less data that can be transferred, but that's adjustable. In nowadays situations, European Chinese networks that we've been into, there's not really things. If we talk about 300, 400 scalar values, there's not really, and some strings, it's not really an issue. I can show you later on the smartphone what we have in terms of data out and so on.
Okay, thanks.
Welcome.
Let's thank the speaker again.
Thank you.